I'm a presenter of Team6, 이재우. Before starting our presentation, let me remind you of our previous presentation content related to this week's presentation. Absolute tower has three challenging problems due to the rotating slab. First one is structural problem. Second one is impossibility of using flight tables. Third one is large thermal transport. During the explanation about structural problem, we mentioned about the self-consolidating concrete. Because of the twisted design, the building required an innovative structural design method. Different from column structure, load-bearing wall supports each slab with sustaining vertical loads. And absolute tower is flat plate structure building, so there is no beam at the building. For these reasons, absolute tower needs concrete that has high intensity 70 MPa for the load-bearing walls, 50 MPa for the slabs. We suggested self-consolidating concrete for the solution of intensity problem. Today, we will explain the reason why absolute tower had to select self-consolidating concrete for the construction of the building. From now on, we are going to explain two main reasons why structural engineers had to use self-consolidating concrete. In case of the general concrete, air voids appear in the process of concrete placing. Entrapped air appears as an empty part inside and outside. However, this air void has a negative effect on the strength and durability of the concrete. First, to talk about the relationship between strength and air void, the more air holes there are, the greater the loss of concrete strength appears. Secondly, in terms of durability, an external substance enters the air void, which can cause a chemical reaction with concrete. Therefore, the more air voids there are, the weaker the durability of concrete becomes. Therefore, it is important to make sure that there are as few air voids as possible, and the common way to solve this is the compacting concrete process. After going through the compacting concrete process, many of the internal air voids gradually decrease. However, In terms of the absolute wall tower, according to the high tensile force demands due to complex load support, the steel bars, which are larger and thicker than normal buildings, were arranged tightly. Then, in the process of compacting concrete, when applying vibration to concrete, the rebar are too dense and are arranged tightly, which cause a collision with each other. This leads to structural unstable situation. Therefore, for absolute wall tower, the method of removing air void with the compacting concrete process is not available. The alternative to this is self-consolidating concrete. The second reason why the engineers had to use self-consolidating concrete is high flowability. To operate as a high-performance concrete, high strength, high flow, and high durability are needed. Strength, flowability, and durability have correlations with each other. Let's talk about strength and flowability. It means the relationship between workability and concrete strength. If water content of concrete declines, the strength of concrete inclines, but flowability will be decreased. Conversely, when water content ratio inclines, the concrete strength declines and flowability inclines. The self-consolidating concrete used in a way to increase flowability while maintaining sufficient strength to withstand the vertical load. The flowability is significantly different in the self-consolidating concrete compared with ordinary concrete. Next is a video comparing ordinary concrete to self-consolidating concrete. At first, the rebar is equally placed out, but self-consolidating concrete is easily and quickly poured with less manpower, while ordinary concrete goes through many processes. So there is a difference in time. And as shown in the video, ordinary concrete requires power floating to smooth the surface. But self-consolidating concrete does not need such a process. The time difference between the two processes becomes bigger. To understand difference of normal concrete and self-consolidating concrete, take absolute tower as an example. When concrete is poured on the middle of the slab, normal concrete with low flowability couldn't spread at the edge of slab. So, edge of shape is still sustained empty space. However, in self-consolidating concrete, there is a different properties. In this case, concrete could fill all over the space, even that is empty before. There are references of this presentation. Thank you for watching.